So here we determine the length of the wire which hangs between the two poles, between the interval x equal to negative b to x equal to positive b. And we have been given the equation of the length of the wire, which is given as y equals c plus a by 2 e raised to the power of x by a plus e raised to the power of negative x by a. So for this, we have to utilize this length of curve formula, which says that L equals x equal to a1 to x equal to a2 integral of 1 plus dy by dx quantity square under the root dx. So basically we'll be utilizing this formula to determine the length of the wire. So we will first find the dy by dx using the given equation. So first let me copy this equation, that is y equals c plus a over 2 multiplied with e raised to the power of x by a plus e raised to the power of negative x by a. We will find the derivative. So I'm going to find the derivative on both sides. The derivative of y with respect to x is dy by dx, and the derivative of c, which is a constant, so this becomes 0. And here we apply the constant multiple rule, that is the derivative of a by 2, which is a constant, it will become a by 2. And then we have to find the derivative of each of the terms, that is e raised to the power of x by a plus e raised to the power of negative x by a. Derivative of e raised to the power of x by a is e raised to the power of x by a. And then when you apply the chain rule, we have to find the derivative of x by a, which in fact is the 1 by a. And similarly, for the other term, derivative of e raised to the power of negative x by a, and applying the chain rule to find the derivative of negative x by a, we will get negative 1 by a. And so we simplify this dy by dx. So therefore this becomes dy over dx equals a by 2. We see that this 1 by a can be factored from this two terms. So I'm going to factor this 1 by a. So therefore this becomes e raised to the power of x by a. We have a negative over here, so this becomes a negative of e raised to the power of negative of x by a. So we can cancel this a with this a. So therefore this is equivalent to, we write this in simple form as dy by dx equals e raised to the power of x by a minus e raised to the power of negative of x by a all over 2. So this is the simple form of dy by dx. And now we will square both sides because we want dy by dx quantity square. So let's square on both sides. Just square it up like this. So when we square this up, I'm going to write down this numerator in just as a square term. I'm not going to expand for now. So I write down like this: e raised to the power of x by a minus of e raised to the power of minus of x by a quantity square all over 2 square is 4. So this is dy by dx quantity square. Now since in the formula we have to add 1, we will add 1 to both sides. So therefore this becomes 1 plus, and here also I'm adding 1 to this side. So therefore this can be written as, we will have to simplify this part. So let me write down this e raised to the power of x by a. In fact, now I'm going to expand this. So this becomes uh, square of e raised to the power of x by a. We have to square this first. So this means that this will get multiplied with this power. So basically e raised to the power of 2x over a. So when you square e raised to the power of x by a, we get e raised to the power of 2x over a. And then plus, once again we have to square this term. So square of this will be e raised to the power of negative 2x over a. And then we have to put minus 2 times of product of these two terms. That is e raised to the power of x by a times of e raised to the power of negative x by a. So when you add these powers, this will become 0. So e power 0 will become 1. This is e power 0. This equals 1. So negative times to negative 2 times of 1, we will write down, and divided by 4 plus 1. Now we will simplify this fraction. So this equals, This 1 we can write down this as 4 over 4. So therefore this becomes, we can make this as a common denominator. That is, so 4 is a common denominator. So I'm just removing this and writing this as we had a 4 over here all over 4. So now we see this negative 2 plus 4 equals a positive 2. So let me write down. So therefore this becomes e raised to the power of 2x over a plus e raised to the power of negative 2x over a plus 2 divided by 2. In fact, this can be, I'm sorry, this is divided by 4. So we write down 4 here. In fact, this numerator term can be written in square form like this. That is e raised to the power of x by a plus e raised to the power of negative x by a quantity square divided by 4 can be written as 2 square. Now this can be written in another simple form as e raised to the power of x by a plus e raised to the power of negative x by a over 2 quantity square. So this is on the left side we have 1 plus dy by dx quantity square. And when we look at the formula, we have to take the square root of this part. So we will now take square root on both sides. So I'll take square root like this, take a square root. So when you take the square root, this is in square term, the square and the square root term will get cancelled. So therefore, this is basically equivalent to e raised to the power of x by a plus e raised to the power of negative of x by a over 2. So this is equivalent to this expression. We will now substitute this expression into the formula with the corresponding limits. We see the lower limit is negative b and the upper limit is positive b because the wire goes from negative b to positive b. So for the formula, we will substitute a1 equal negative b and a2 equal positive b. So let's rewrite this expression with the correct formula. That is L equals 1 plus, this is the formula I'm writing, dy by dx quantity square under the root x equals a1 to x equals a2 dx, and this equals integral x equal to a1 is negative b and this is positive b, and we have already found this expression, that is e raised to the power of x by a plus e raised to the power of negative x by a over 2 dx. So now we have to basically integrate this expression inside the integral and evaluate within the limits of negative b to positive b. So first I'm going to factor this 1 by 2 out of this integral. So this becomes 1 by 2 times of negative b to positive b e raised to the power of x by a plus e raised to the power of negative x by a dx. So we can in fact rewrite this integral using property of integral. That is, suppose if we have a function that is the integral defined between negative a to positive a of f of x dx, this equals twice of integral of 0 to a f of x dx if f of x is an even function. That is, if f of x equals negative of f of minus x. I'm sorry, if it is equal to f of minus x. So considering this as f of x, let's verify if this is an even function. So if this is f of x, we'll find f of negative x. So for that we have to replace x by negative x. So the first term will become e raised to the power of negative x by a plus the second term will become e raised to the power of negative x is positive x. So this becomes e raised to the power of x by a. In fact, this term, this expression, as well as this f of expression is both the same. So therefore, f of minus x equals f of x. So which means it satisfies this condition. That is so that we can use this property. So I'm going to rewrite this integral as 1 by 2 times of 2 times of, instead of the limit from negative b to positive b, I can now rewrite this limit as 0 to b, and the expression that is e raised to the power of x by a plus e raised to the power of negative x by a dx. So we now see this 2 and this 2 will get cancelled, and finally we have to evaluate only the integral from 0 to b of this expression. So we can split this into two integral, that is 0 to b e raised to the power of x by a plus integral of 0 to b e raised to the power of negative x by a dx. Now we will integrate this expression. Integration of an exponential expression is e raised to the power of x by a and divided by the differential of the x by a, which is 1 over a. We have to evaluate between 0 to b, plus similarly this will be e raised to the power of negative of x by a divided by the differential coefficient of negative x by a, which is 1 negative 1 by a, and we have to evaluate between 0 to b. So let's apply or we will first simplify and then apply the limit. So this becomes a times of e raised to the power of x by a from 0 to b, and this becomes negative a e raised to the power of negative of x by a. Apply the limit from 0 to b. So first let's apply the upper limit and lower limit for this expression. So therefore this becomes a times of e raised to the power of instead of x we write b by a minus of when you apply the lower limit this becomes e raised to the power of 0 minus we have a times of e raised to the power of negative b by a minus e raised to the power of negative 0, which is negative 0. I write down. So let's simplify this. So I'm going to distribute this a with the terms inside the brackets. This becomes a times of e raised to the power of b by a minus e raised to the power of 0 is 1. So a times of negative 1 is negative a minus a times of e raised to the power of minus b by a. And once again, this e raised to the power of negative 0, this is also 1. So therefore, negative a times of negative 1 is positive a. We now see that we can cancel this negative a with positive a. So finally, we get the expression, which is a times of a e power b by a minus a e raised to the power of negative b by a. In fact, this can be, the a can be factored, and when you do that, we get a times of e raised to the power of b by a minus e raised to the power of negative of b by a. So this is the length of the wire.